Jonathan here. Back working here. It's hot as can be. I got the fan running, but it's still hot. Just pushing through it. I went ahead and turned this clutch hub down how I want it. Went to Lawrence's, my buddies, and picked up our chunk here. This, believe it or not, is 16 pounds. And you know, we're going to get what we need here. First thing I'm going to do is bore inside to actually press over this. And then we're going to go from the back side. We drill these 6 holes into our flywheel, or whatever you want to call it. It's going to be a pulley actually, but we're going to drill them holes, and then we're going to bolt it with all 6 bolts onto it. And of course, like I said, I'll turn the inside out, and so it'll slide right over it good. And then we will be holding it on the crankshaft with a single bolt coming through into the crank, and that'll hold everything together. Should do just fine. And we're going to lose a lot of meat on this when we go to turn it. I think we're going to run it for an 1.5 inch belt, and we'll face some of it off and maybe countersink for the bolt. We'll do something, we'll change it around, but that's how it's going to go. And you know, went ahead and turned this down to where I want it, and we'll get at that. And let me see, I got my broach in, so we can go ahead and get started on the keyways for the gear and the sprocket. And I believe that's about it. I've got the piston on, and I don't have the clips on it yet, but everything's done on the top. You know, the new bushings in, all that good stuff. Got to do some cleaning up here. All that goopy looking stuff and all that was where I used that spray glue. Kind of made a mess, but anyway, we will we'll get at it. I hope to go ahead and get a gasket made, and we'll get the cylinder on it permanent, and we'll get this flywheel done, and then we'll go get these keys. So you know, we're on the home stretch. So all right, show you more. Okay, folks, we've got this machined out and ready for our piece to go in. We're going to go ahead and press it down in it. It's kind of tight, so hopefully, I don't think I'll need to take it back out. I'm just going to machine it off here. We're going to do the pulley groove, and then we're going to shorten this up some, but I can check it from the other side. We're going to go ahead and, well, I guess I do got to pull it, because I'm going to have to take it off to tap the holes. But you know, we got a lip here still, just a little bit bigger, so we'll be able to get it off. But anyway, I'm going to go ahead and drill these holes down in, get them tapped and done and bolted together. All right. Okay, I want to show everybody my broach I got. I've never broached before, believe it or not. So we're going to learn, but not much to it. Seen it done, just never done it. Not sure the quality of this. It's made in Poland, but not Chinese anyway. And that thing's about $30, well over $30, so they're not cheap. So anyway, we'll make the pieces and get the broach in here a little later, but we'll keep on this this pulley and try to get it done. Okay, folks, I've got our hub pressed in, bolts in it, tapped, done. Trying to turn out for the pulley, trying to do this out to 1.5 inches for an 1.5 inch wide belt, and then I'm going to face what I can off of here. But we're moving right along. I had to bring it out a little ways, and the reason being, I've got this pressed in 1/2 inch, 500 thousandths, and I didn't want to get anywhere close to it to make this ring weak. So we left it out at 3/4 inch, which will give us some clearance too. It's going to work out really good. We're just trying to get this belt groove cut in it, and then, like I said, face it off. And I may countersink this bolt. I've got a bolt for it. I got 3 different lengths for it. Just make sure I get the right length. It's a metric. It's a 10mm 125 pitch, and so anyway, we'll get that. And let me see. I think that's about it. I don't think there's anything else to show you for tonight. We'll see though. All right, folks. Next day, I worked as long as I could out on one of the rollbacks, and got a heat index today of 115, so it's gotten too hot pretty quick, so I figured I'd come back in here and shop, or at least I could turn the fan on and get back to work on this pulley. Still got to go deeper and face the front of it off, and I'll get this finished up. Okay folks, finally done with this pulley. Took some time. I'm going to weigh it again and see how much weight I took off. It was 16 pounds before. I put a little bit of a taper on the edge here. Maybe hard to see on camera, but come out really good. 1.5-inch belt. I brought it out far enough to where it wouldn't interfere with our 1/2 inch that we have it pressed in. Turned down between the hub and this. So that's all you're going to see is this aluminum line around it. And I'm hoping I didn't screw it up too bad when I chucked it in, because I did tighten it really tight. So I dial indicated it in, you know, to machine this side of it after I'd done the other side. So we'll get it off and look at it. Okay, it's on. Looks kind of wide, but it won't look bad when the belt's on it. We needed that extra weight anyway, and I guess I need to, I haven't weighed it yet. Our bolt has got a little bit of a shoulder on it, and what I did was actually bored the hole out to fit that shoulder, so that'll even help more. And should have plenty of threads here before it hits bottom. Oh yeah, that'll work really good. So that'll tighten down good. And what that does is it actually sandwiches or sandwiches, depending on where you're from, the hub to our piece that we made for our seal, or you know, a seal bushing, and then it goes all the way in and goes up against the center of the bearing, the inner race, and of course that goes up and against the crankshaft. So you know, basically it just smashes it all together. You see a couple little scratches here where I had it chucked, but it wasn't nearly as bad as I thought. But after we get it running, we can take care of that. But that's going to work out really good, and I'll show you the back side of the pulley. Let me see. Thing's still hot, so let me get my glove on. Okay, not much of a glove, but it'll keep me from burning my hand. There you go. We got 5/16 bolts and got lock washers on them. They're bolted down good and tight, so no worries about anything coming apart. So like I said, you can't see any of this when it's on, so seal's in it. So anyway, let me weigh this thing and I'll let you know what it is. Okay, we started out at 16, we're at 11 now, so I actually machined 5 pounds off of it, and so it shouldn't be a problem. Okay folks, I wanted to explain to everybody why I'm running such a heavy flywheel. You know, some people I'm sure don't understand. This is a 2-stroke crankshaft. A 2-stroke fires every rotation, and so the weight's not going to be as heavy as a 4-stroke crankshaft, because it doesn't have to power itself through, you know, the extra stroke or the extra rotation, where this one does. And that added weight will help. Now these engines, early engines, would have ran a lot bigger flywheels on the crankshaft than what I'm running. So you know, we've just went with a happy medium to try to make it look decent and still be enough weight to run. So that's why that's so much weight there. And like I said, it started out 16, now it's 11 pounds. And it will cut back on throttle response, but you know, it'll allow it to idle, should be idle and slow and steady, and that's what I'm looking for. I'm more worried about a good runner, good smooth runner. Anyway, let's get the key, cut some keyways. Okay folks, set up on the arbor press here. Here's my piece I made. This just fits in and has a slot, 1/8 inch for our cutter. And let me see. Of course, we're going to use a lot of oil. This is an old 4-jaw self-centering chuck I like to use. It's really good to hold stuff when you're using the drill press, or you know, something like this. You know, when you're trying to hold a round part. And I can just take it and set it right down on the drill press. So anyway, that works really good. Now, the way this works, is it's stepped up. So let me raise this up a little. So this is going to slide in and start, and then it's going to push through, and then we'll shim it, push it through again. Hopefully when we're done we have a nice keyway broach, but we're fixing to find out here. Okay, we ran it through, and then we ran it through with the shim. Let's hope it turned out good. We'll have to pop it apart and see. Worked out better than I thought it was going to. We'll see how it turns out. Yeah, I think I can measure it from the bottom, so I'm going to measure that and make sure. It looks right though. We'll measure it and make sure it's right, and then we'll knock our piece out. Shouldn't be in there too tight anyway. Alright, show you when I'm done. Okay, measured out good. It's going to work good, fit good, all that good stuff. So that's my first keyway I'd ever broached, but we will, I'm sure eventually invest in some more broaches to, you know, do some more different sizes, but worked out really good. And I think the last ones I had done was $20 a piece is what I was charged to broach. So, you know, a couple times and you paid for your tools. So. All right, show you more. Okay, folks, we've officially got it in time. And it looks good. I like it. I'm happy where it's at. That's why I left the top end off, is because I wanted to be able to really test it like I want. So here's how it starts. Now we're exactly 180 degrees out right now. So we're not on top dead center. We're one full rotation off of top dead center on the crankshaft. And we're 180, which is half of a turn out on the cams from being top dead center. Top dead center is where, you know, basically you're firing at, or you're firing just before top dead center, but you know, that's where everybody sets it from, because it's ignition timing. So when you're working with valve timing, it's a little different. So our engine's going to rotate clockwise, so I've got our cams set up for that. If it was going to rotate counterclockwise, they would be set up opposite. Basically, this lobe would be pointing this way, this one would be pointing this way, and as soon as I moved it, it would be opening the intake valve when I went counterclockwise. But the way I've got it now is when you turn it clockwise, it's going to open the intake valve. Now, just to give you an example, I've got the Briggs cam here, and as you can see, let me get the lobes where I want them. Okay. As you can see, one lobe here and one lobe here. No matter what, you can't change the rotation on this engine unless you could swap these lobes out. This lobe would have to be over here and this one will be here. We can do it on our engine because we've got separate lobes. So, you know, one's intake, one's exhaust. I don't know which is which on the Briggs, but either way, to change rotation on a Briggs, if you ever wanted to, of course nobody's going to want to, you would have to actually change lobe. This lobe would have to be here and this lobe would have to be here. Or you could actually probably do it and use the intake for an exhaust and the exhaust for an intake, actually on the block. So I mean, you could actually do some changing and make it run backwards if you really wanted to. But and then of course you have to change your valve timing or your spark timing to get it to fire before top dead center. My light just came back on. And our top dead center, I mean our firing, we're going to fire with our adjustment arm magneto. You know, we need to go from like 30 before to 0. If we can get it to vary between there, we'll be just fine. But I'll show you what this does. And you know, top dead center is where everybody starts at, everybody times at. But really that's not the start of the stroke. You got a 4-stroke engine. This is the start, which is 180 degrees out. Okay, we're going to go clockwise. We're just going to turn it a little bit. And as you can see, this intake valve, as soon as I start turning it, started opening. Okay, so it's going to turn over. It's going to go to the bottom. And then it's going to be coming back up. It's kind of hard to turn like that. It's going to be coming back up. It's closing. And as it comes up, we're building compression. As we build compression, we get right before top dead center. It fires, comes on over. This is the power stroke coming down. And as you can see, when it gets to the bottom, our exhaust valve begins to open. When our exhaust valve opens, that lets the exhaust out. Okay, the piston's pushing up to push the spent fuel out. It comes back to the top. And now we're back where we started. Our intake valve's getting ready to open again. So basically what I've got is I'm 108 degrees out on the cam, I'm 360 degrees out on the engine, but if I go clockwise with the engine, you'll see the intake valve will start to move. If I go counterclockwise on the engine, the exhaust valve starts to move. So that's that happy medium where we need to be. And then we go one rotation. That's top dead center. So what I'll do is I'll go ahead and broach our sprocket, put our sprocket on, and then I'm going to put a mark on our sprocket directly up so we know where top dead center is, and that way we can do our spark timing. So, but our timing for our cam is, or for our valves is done. Keys in, we're ready to go. We're going to keep working at it. All right, show you more. Okay folks, we've got everything in, tightened up, ready to go. I've got the seal in the front cover. Let me get it. I've got the seal in it. Got the gasket cut out. I machined an area out for the bolt, and you know that piece that protrudes out a little bit. Everything else is good. We're going to get this cover on, and this will be the final time. I'm going to shoot some oil in there first, of course, but we'll keep rolling along. Okay, folks, cam cover's officially on. Seal's in. Went in fine. Worked out really good. I still have not keyed the sprocket yet, and one of the reasons is I kind of messed up, went a little bit big on it, and so I'm going to actually bore this one out. I've got plenty of these, but I'm going to rebore this one for the exact size, and then I'm going to key it. But you know, it's not a problem. I can take it right off. Oop. And anyway, it's there for good, and no binding, no problems. Put a gasket between it, put sealer on it, and so next is the cylinder. Everything's honed and ready to go. Still got to make the gasket. Let me see. I've got a little bit of grinding to do on the top and a couple of holes to tap. So we're going to go ahead and get on that next, and then we're going to try to do a compression test on it. If I can get something to spin it to where we can, you know, just check compression once the valves are, you know, stuck on and on. I'm sure it's going to be fine, but everything seems to be working out really well. You know, no major downfalls. My only worries, I had a dream the other night that the cylinder blowed off the block, so I don't think that's going to happen. But now my only real worry is oil leaking out from around these these lifters, and if it does, we'll work with it. We'll figure out what we're going to do. But there's just so much oil moving in there. I had no idea, and just rolling it over by hand, you know, it's bringing the oil right up. So, and you know, the level's not that high. It's not a, you know, it's not a real high level in it. And so anyway, we'll get back on it maybe tomorrow if I get time. I appreciate everybody watching. And oh, let me add in there, Mark Lindsay, he finished up that vise, and I keep forgetting. I want to put a link in the description. Everybody check that thing out. It come out really good. Mark's a man of his word. He said he'd redo it, and he redone it. He's got it back to where he can work and use it. So we'll probably be doing another giveaway here soon. So, but yeah, check out Mark's channel and check out his completed Wilton vise. And appreciate everybody watching. Till next time, bye.